Welcome to the session on numerical methods, locating roots. The objectives for this session are to locate roots of f of x equals 0 by considering changes of sign. A root of a function is a value of x for which f of x equals 0. The roots of the function correspond to the points where the graph of y equals f of x crosses the x-axis. It can sometimes be shown that a root exists within a given interval by showing that the function changes sign within the interval. We will now look at continuity, signs, and roots. Suppose the function f of x is continuous on the interval ab, and f of a and f of b have opposite signs. Then f of x has at least one root x, satisfying a less than x less than b. Intuitively, we can think of continuity in terms of not having gaps in the graph, or when the function does not jump, so to speak. Let's now take a look at a couple of examples. This graph is a continuous function. There are no jumps in this graph. And this graph on the right is not a continuous function. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. The diagram shows a sketch of the curve y equals f of x, where f of x equals x cubed minus x plus 3. Explain how this graph shows that f of x has a root between x equals minus 2 and x equals minus 1. So let's solve this. Notice that the graph crosses the x-axis between x equals minus 2 and x equals minus 1. At this point here. Therefore, a root of f of x lies between x equals minus 2 and x equals minus 1. Since the graph of y equals f of x crosses the x-axis whenever f of x equals 0. Let's now take a look at part B. For the same function, we are required to show that f of x has a root between x equals minus 1.7 and x equals minus 1.6. So let's solve this. We take a look at the point x equals minus 1.7 first. If we plug this value into the function f of x equals x cubed minus x plus 3, as shown here, we obtain f of minus 1.7 equals minus 0.213. And similarly, if we plug in x equals minus 1.6 into the function f of x equals x cubed minus x plus 3 as shown, we obtain that f of minus 1.6 equals 0.504. So we have that f of minus 1.7 is negative and f of minus 1.6 is positive. Clearly, this means that there has been a change of sign between minus 1.7 and minus 1.6. So f of x changes sign in the interval minus 1.7, comma, minus 1.6. And therefore, f of x must equal 0 in this interval. And so there is at least one root between x equals minus 1.7 and x equals minus 1.6. Let's now take a look at some special situations. Consider this function y equals f of x in the interval ab. Notice that a maps to a positive value and b maps to a negative value. Notice also that there is an odd number of roots. In this example, there are exactly 3 roots on the screen. So, a change of sign does not imply exactly 1 root. Now let's take a look at another scenario. Here's a function y equals f of x in the interval ab. Notice that a and b both map to negative values. But also note that there are multiple roots within the interval. In fact, in this example, there are exactly 2. Often, but not always, whenever a and b map to the same sign, we have that there are an even number of roots within this interval. So, no change of sign does not imply no root. Now let's take a look at this example. Here's y equals f of x in the interval ab. Notice that a is mapped to a negative value and b is mapped to a positive value. Something else which is special about this graph is the asymptote which you can see in the center. So in this graph, a change of sign occurs, but there is no root. We can't apply the change of sign rule. And this is because the graph is not continuous. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, a student notes that the function f of x equals 1 over x plus 3 for x not equal to 0 has a change of sign in the interval -1, 1. The student writes the following. Since y equals f of x has a vertical asymptote in this interval, despite the change of sign, f of x has no roots in this interval. Explain why the student's claim is incorrect. So let's solve this. Here's a sketch of the curve. Notice that there is an asymptote at y equals 3. There is also an asymptote at x equals 0. If there is a root in this interval or anywhere in this graph, then f of x equals 0 at that point. This implies 1 over x plus 3 equals 0. In other words, 1 over x equals -3. Or x equals -1 over 3. Here in the graph. So the existence of an asymptote in an interval does not necessarily mean that a root does not exist. And now for another example. Pause the video and have a go. Press play when you're ready to view the solution. Let's consider part A first. A function is defined as f of x equals sine 2x plus e to the power 4x. Show that this function has a stationary point alpha in the interval -0.9, -0.8. So let's solve this. If we differentiate f of x, we obtain 2 cos 2x, here we've differentiated sine 2x, plus 4e to the power 4x. This is of course the differential of e to the power 4x. If we plug in x equals minus 0.9 into the equation for f dashed of x, we obtain that f dashed of minus 0.9 equals minus 0.345. This is of course less than 0. And if we similarly plug in x equals minus 0.8 into the formula for f dashed of x, we obtain f dashed of minus 0.8 equals 0.105. And this is of course positive. So f dash of minus 0.9 is less than 0, and f dash of minus 0.8 is greater than 0. So there is a change of sign, which implies a turning point. In other words, a point at which f dash of x equals 0. Now let's take a look at part B. We are required to verify that alpha equals minus 0.823 by considering the change of sign of f dash of x in a suitable interval. So let's solve this. Here's our equation for f dash of x. Let's now consider f dash of minus 0.8235. Notice that this is the lower end of the endpoint for minus 0.823. And plugging this into the equation for f dash of x gives us that f dash of minus 0.8235 is equal to minus 0.0038, which is of course less than 0. And similarly, f dash of minus 0.8225, which is at the upper end of the interval for minus 0.823, is positive. So the change of sign implies that alpha is greater than minus 0.8235 and less than minus 0.8225. And therefore alpha equals minus 0.823, correct to 3 decimal places. This brings us to the end of this session. If you have understood its contents, you should be able to locate the roots of f of x equals 0 by considering changes of sign. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.